The idea in this is to start with one side and make it look exactly like the other side. So let's start with the left side. Sine 2x. Well, sine 2x is the same as sine of x plus x, which is sine x cos x plus cos x sine x, which is the same as sine x cos x plus, switching these around, sine x cos x. And then you say to yourself, 1 sine x cos x plus 1 sine x cos x is equal to 2 sine x cos x. I'm going to use the same strategy, left side. Cosine 2x is equal to cosine x plus x, which is the same as cosine x minus sine x sine x. But cosine x times cosine x is cosine squared x, and sine x times sine x is sine squared x, which is the right side. We know that cosine 2x is equal to cosine squared x minus sine squared x. This is from our previous identity. Now that we know it, we can't unknow it, so we can use it. So we can say this is the same as cosine squared x minus, and instead of sine squared x, I'm going to replace it with 1 minus cosine squared x. Now I can do that. I'm just going to move to the side here, because I know that sine squared x plus cosine squared x is equal to 1. So I can move the cosine squared here, and that'll tell me that sine squared x is equal to 1 minus cosine squared x. That's where I got that from. Alright, that's equal to cosine squared x minus 1 plus cosine squared x. And when you add cosine squared x and cosine squared x, you add them up, that's going to give you 2 cosine squared x minus 1, which is, you guessed it, the right side. We know from the previous example that cosine 2x is equal to 2 cosine squared x minus 1. And what I'm going to do is I'm going to write 2, and instead of cosine squared x, since sine squared x plus cosine squared x is equal to 1, cosine squared x by itself is equal to 1 minus sine squared x. So I'm going to put that into here. So I replace cos squared x with 1 minus sine squared x. This is going to give me 2 minus 2 sine squared x minus 1. 2 minus 1 is 1 minus 2 sine squared x, which predictably is the right side.